Hello, my name is Simon Julia and I'm the course director for the MSc in Robotics and Artificial Intelligence. In this virtual open day presentation, we want to go through and describe a little bit about the MSc itself, so the motivation of why study robotics in the first place. Then we want to go through a little bit, look at how the MSc is going to be structured. We'll look a little bit about how it's going to be taught, some of the projects that you can do, some of the resources that are available, and some of the options that will be available after you complete your studies. Okay, so let's start. Why are we interested in studying robotics? And the reason why is that robotics is a profound influence that has changed and is continuing to change the world that we live in today. So first of all, if we think about how the world has changed, or the robots have changed the world, let's think of, for instance, car manufacturing. So what we've got here, there's a car that's being built and all these robot arms are being used to assemble this. Robots have been used to assemble cars since the 1970s. So that's about 50 years. So what that means is that almost any car you will have seen on the road, or any car that you have ridden in or driven, will have probably been built or partially built by a robot. Another example is we think of stuff like warehouse and delivery. So, for instance, this is from Ocado, which is a food delivery chain in the UK. But for instance, Amazon have their own, enormous kind of warehouse logistics, robotic systems that are used. Many other manufacturers, many other suppliers do as well. So robots are completely changing the way the logistics work. For example, ports are being automated as well. So the way stuff gets moved around is being completely revolutionized by robots. We're seeing as well transports being revolutionized. So for instance, these are a couple of the GM Cruise self-driving vehicles. And we know, for instance, with Tesla and so on, that these are becoming more prevalent and more common. But of course, robots aren't just restricted to the Earth. So, for instance, this is the Ingenuity drone that recently completed its mission on the surface of Mars. So robots are not restricted there. They're going all over the place. And this is just a tiny subset of the application of robots. Robots are being used in construction. They're being used in healthcare. They're being used increasingly in the home as companions or assistants. They're being, you're seeing robotic pets and so on for people, for instance, who are lonely. And so there's a huge migration away from these kind of like large, complicated systems and these kind of interesting and challenging environments to stuff that becomes more everyday and more open with it. And the more kind of everyday that robots become, the bigger the influence, the visible influence they're going to have on our daily lives. So given that kind of background then, well, the reason why was we wanted to have an MSc was to really be able to, given all the opportunities and all the changes, to produce a group of scientists and engineers who can really shape the development of this in the future. So to do this then, the MSc is designed to give you kind of like two sets of complementary skills. The first one is to use the systems and services, so all the different algorithms, systems, hardware systems, software systems, and so on, to create things like new products and services. So for instance, how can we use them to create robots that will build better buildings or be able to move materials around more efficiently? But we also want to be able to have this as a grounding for people who want to create the next generation of robotic systems, for instance, doing fundamental research that will make them even better. This could be, for example, they're more efficient in power or energy, or they do less environmental damage, or they're more ethical. But there are many different ways that you can cut this. And so the idea is to have people who really understand robots and they want to create them and create better versions of them for our future. So what kind of people is this degree suited for? The first thing is that people need to be multidisciplinary. And by this we mean is that people who really enjoy the fact that robots cover multiple different areas simultaneously. A robotic system is not just a computer program which runs. It runs on a piece of hardware. It takes sensors in. It has to control, for example, motors and actuators. So you have to worry about electrical engineering, mechanical engineering, machine learning, graph-based search algorithms, stochastic optimization, many different sort of kind of disciplines and areas of study that all converge together to create these robotic systems. And the first thing is anybody who's interested in robotics has to have that real passion and desire to do this. The second thing is you do need to be capable mathematically. We're looking at a lot of topics which are, can be mathematically very challenging, from linear algebra in very, very high dimensional spaces to complicated nonlinear manifolds that describe, for example, the relationship between joint angles and the end of the movement of an arm. The final thing is that you need to be familiar and comfortable with programming. You don't need to be the best programmer in the world, but you need to be someone where if you're given, for example, a piece of code that you have kind of, willing to crash into it, to understand it, pull it apart, figure out what makes it work or not work, to be able to identify, for example, when it's going to succeed and when it's going to fail. So we've seen now the motivation that robotics is going to have a profound influence on our lives. You can see kind of what we wanted to get out from this module, or this particular course. So how is the course put together? What are the key components of it? So this is kind of a timetable that shows the structure of the course over the year. So you start in the summer. So think of this is kind of like July to September time. What will happen is there'll be some material available. This is optional stuff. This will be some background on the maths and some of the coding and some of the systems that we use. We know there are very, very good resources out there, but we want to provide our own. So sort of everybody's got a unified base to work with. And for example, it will be looked at in a robotics context. The autumn term, and this is the one that runs from September to December, is structured a little bit differently from the way most MSCs are structured at UCL, because we use an approach called block teaching. So what we're going to do is, this is the first 5 weeks of term, and then there's a 1 week break and the second 5 weeks of term. And in the first 2 5-week blocks, you just study estimation and control and machine learning for robotics. And so the idea behind looking at those modules is they're looking at the fundamentals. So again, we want to make certain that people, understand what control systems are, what noisy sensors are, how you can characterize them, how you can do estimation and a stochastic inference off of that. Similarly, to understand what are the basics of machine learning systems, what are they, how do they operate, what is good practice and what is bad practice about how they will and won't work. The second half of the first term will look at modelling and motion planning and computer vision and sensing. So modelling and motion planning, this is looking at the fact that, robots are unique with autonomous systems in that they actually move. And to do that, they need to be able to describe their own bodies, and they need to be able to decide what is the sequence of actions that will, for example, move an arm from one configuration to another one, or move a robot to drive a robot from one position to another one. The computer vision and sensing then looks at the different kind of sensing systems that robots use to monitor their environments. Computer vision is the dominant one, but it's not the only one by any means. Robots, for instance, if they're underwater, will use sonar systems, and if they're, for example, in a smoke or a fire like a burning building, they'll often use radar. The second term then, this runs from January until March. This consists of one final mandatory module on localization and mapping and 3 optional modules. In the mandatory module, you're going to look at how robots can estimate and figure out where they are in the world and what the world looks like around them. We're going to look at, for example, the algorithms that underpin the way systems like Street View work, and also things like how, for instance, a HoloLens and an Oculus Quest work, because there's strong relationships between VR and robotics and tracking. Well, then, as I say, we're going to look at optional modules. There are several kinds of optional modules which exist. So, for example, we've got modules on aerial robotics, soft robotics, and legged robots. So these are all about specific kind of systems of specific embodiments of robots. There's going to be stuff, for example, on manipulation and further detail on object recognition. And these are more about how do you do inference and kind of understanding of the environment. And then finally, we've got some modules related to human-robot interaction, things like teleoperation and how people instruct robots to carry stuff out with that. Once you've completed, this is kind of the talk component of this, the last thing you do is the project. And this runs from about April time until September. And the idea behind the project then is you take all of the skills and practices that you've learned so far and you apply them to tackling different kinds of challenging problems. So here's just a couple of examples of projects I wanted to just show to illustrate this. So this is from our MSc Robotics and Computation. So what we've got here, for instance, this is a Boston Dynamics Spot robot that can run around a bit like a dog. It's legged. It has a sensor that's fitting on there. This is called an Intel real sensor. And that will take a regular picture and create something called a depth map as well from this. And what happens is this robot is sent in an environment and it is told to go and find all the fire safety equipment. So it's looking for things like, for instance, the fire extinguishers, safety jackets, and so on as well. And so the robot, for example, will be presented with some data from some stuff in a lab. And for instance, it will then go through and it will segment and process this data, and it will identify and be able to report back to people with all essentially the pieces of equipment you would need to fight a fire should a fire arise. Another example of a system that we do is one that is based off of additive 3D printing. So what you've got here is you've got a mobile robot base that can move, and it has an arm on it and with a print head. And in this particular project, what happened was the print head, or the robot, is trying to repair things which are damaged. So for instance, in this case, it's got a block. There's a hole in the surface of that block, and what it does is it scans that hole and it identifies it. And then what it goes to do is it goes through and it prints it. Now, this system will actually print and deposit material, but for this kind of project, we just said we're just going to go through as a dry run and show the actual, how the robot will print with this. But this shows, for example, how you could take a robot out and it can just spot and it can just repair kind of stuff that it encounters as it goes. Okay, so what about the teaching then? So how is the teaching structured? And that we're going to go through with this. And it turns out what we're going to use is problem-based learning. And this is an example on the right-hand side here of one of those problems that we might ask you to look at. So this is from a module that's looking at robot manipulation. And the problem is this. Here's our robot. It's got this table around it, and it's got a series of objects which appear. It needs to actually figure out where the objects are and pick each object up and put it in this tray at the back. So the first thing that happens is you'll be given lectures and seminars to provide the basic theory. So the kind of theory that you'll be interested in is, okay, how can the robot represent a model of the environment? How can it determine, for instance, how to, if you've got an object, what's the right place you should pick that object up from? You'll look at them, for example, what's the theory about saying, how do we coordinate or orchestrate changing all the angles on the arm so it will get to the right place with a very high degree of accuracy, and how do you control the gripper? And then the final thing is you've got, for example, the actual sensors themselves that are modeling the environment. How do you analyze the data to be able to figure out where those objects are? So what this is going to do this, typically you're going to be working with state-of-the-art tools and state-of-the-art algorithms to understand this. So the idea is that you'll be using the absolute kind of like leading-edge systems which are out there, as part of the teaching, to become familiar with them, to understand what you can and can't do with them. And then what you've got is a series of projects, and these are deliberately fairly open with this. So for instance, you've got how you do the object manipulation here. But it's very much up to you, for instance, how do you want to order it? How do you want to sequence it? Which specific algorithms do you want to try? Also, how do you test? How do you assess? How do you evaluate? And the idea is that really using these exercises and projects is when you can take the theory, you can really see how it works in practice and really sort of get used to it, if you like, with that. Okay, so that's the approach to teaching. What's the environment, the physical environment like that we're going to be teaching in? So we're based over predominantly at UCL East, which is over in Stratford, and there are two main areas. The first one is, this is Marshgate and Paul Street, and I have to apologise, the only picture I could find was when these buildings were being built, but they are open, they're fully operational. And so what we provide, for example, there's a series of labs that we'll see in a minute are based over here, and all the teaching resources and so on are based over in this particular building. Sort of resources we've got available include these. So for instance, we've got motion capture systems that will let you ground truth the movement of a robot. You've got VR systems if you want to do teleoperation. You've got laser scanners, or these are to measure the environment. You've got here and in various other places, there's various legged robots that can move around, but we've also got wheeled robots. We've also got drones. We've also got these little drones that appear here as well. And there's also various types of grippers and various kinds of actuators as well. So there's an enormous amount of hardware and resources that you're able to use. In addition to the UCL East site, UCL has a second building or part of a second building which is called Here East, which is over in the other part of the Olympic Park. And yes, we do get confused between Here East and UCL East on a regular basis. And this contains more large-scale industrial equipment. So, for instance, you can do stuff like, this was work that's being done where you can use drones to do additive 3D printing. So as the drones fly around, they'll deposit material behind them. And you can also do things like construction monitoring. So, for instance, this is a ClearPath Husky robot, and it's going around and it's actually, monitoring all the time, what's being built, where's being built, and so on with that. Okay, so those are the resources. So what about the careers and sort of industry links? So we have links with a number of industries, a number of companies, and also we have, here are some of the kind of destinations that we get from students coming out. So this was actually just going through very quickly, just kind of pulling through from LinkedIn from the last few years. So we've got, for example, people going to sort of more robotics themed areas such as Oxa or Oxbotica, Amazon, Dyson, AI drivers, Jaguar Land Rover, Fox Robotics. But there are also other groups as well. So, for example, there's NavLive, which is a company that builds tracking systems. You've also got, software companies Canonical, who make Ubuntu. You've got banks. You've got space exploration. And so there's very, very broad kind of range of and destinations. And the reason why is because the skills, although we're teaching them specifically about robotics, they also show how really very much the state of the art of how you use machine learning in engineering in almost any kind of system these days. We've also got PhD students studying it, for example, KIST, which is in Sweden, Oxford and King's College as well. All right, well, thank you very much for listening to this video. I hope you find it of interest, and we look forward to hearing your questions and comments.